Alright, so this question reads, a bread truck makes exactly one bread delivery to each of 6 restaurants in succession: Figueroa's, Ginsberg's, Harris's, Kanzaki's, Leacock's, and Malpighi's, though not necessarily in that order. The following conditions must apply. Alright, so we have our inventory. We have 6 restaurants, F, G, H, K, L, and M. We know the bread truck is going to make a stop at each one of the restaurants in a specific order. So we have a sequencing game and there's 6 stops. And now we can go to the rules. Rule number 1. G's delivery is earlier than K's but later than F's. Okay, so we know F is earlier than G and G is earlier than K. So that means K has 2 stops before it. So that means K can't be first and K can't be second. And F likewise has 2 stops after it. So F can't be 6th and F can't be 5th. And we know that G has 1 stop before it and 1 stop after it. So G can't be first and G can't be 6th. Okay, rule number 2. H's delivery is earlier than G's. Okay, so we know H earlier than G, so that tells us that G now has both F and H before it, so that means G can't be first or second. And since we can combine rules 1 and 2, let's just go ahead and combine them. We know we have F and H are now before G and K is after G, so this tells us that now K has 1, 2, 3 stops before it, so K can't be first, second, or third. And now we know that H has 1, 2 stops after it, so H can't be 6th or 5th. Alright, moving on to rule number 3. If F's delivery is earlier than M's, then L's delivery is earlier than H's. Okay, so if F's delivery is earlier than M's, then L's delivery is earlier than H's. Contrapositive, if L's delivery is not earlier than H's, so we know that each delivery is to one of 6 restaurants, so there isn't one delivery to 2 restaurants, so they're going to either be before or after each other. Therefore, saying L is not before H means H is before L. So the contrapositive can be H before L, then not F before M, which is just M before F. Alright, and the last rule, rule number 4, either M's delivery is earlier than H's or it is later than K's, but not both. Alright, so we have 2 parts of this statement. We have an either or statement and a not both statement. So with our either or, we have either M's delivery is earlier than H's or it is later than K's. So if M's delivery is not earlier than H's, remember we can just write that if H's delivery is earlier than M, then M's delivery is later than K. So contrapositive, if K is not earlier than M, meaning if M is earlier than K, then H is not earlier than M, meaning M is earlier than H. So this is the either or part of our rule. Now we still need our not both. So our not both is going to be if M's delivery is earlier than H's, then M's delivery is not later than K's. That means K is going to be after M. Contrapositive, M is not before K, so K before M. Then M is not before H, so H is before M. And this is our not both. Alright, so what rule number 4 is telling us is either M is going to be after both H and K, or it's going to be before both H and K. If H is before M, then K is also before M, so both H and K are before M. But if M is before K, then M is also before H, so both K and H are after M. And normally, if this wasn't an either or not both situation, we can see from the necessaries of the rule and the contrapositive that we could have K before M and H after M, but the not both eliminates that possibility for us. Because once we have one of our necessaries, let's say K before M, that's going to then trigger the contrapositive of our not both statement, making sure that H is also going to be before M. Similarly, if we have M before H, that's going to trigger our contrapositive, and so we're going to have M before K, meaning H and K are both after M. So we know that we're either going to have H and K before M or M before H and K. So this helps us make a huge deduction by drawing out both of these options, either HK before M or M before HK, because those are the only two options. So far we have this as our diagram. Now, we're going to have M either before HK or after HK. So if we have M before HK, all we need to do is draw M before H, and that would clearly make M still before K as well. So let's write this option out here to the side. Our first option is that M is before H and K. So we have M before H. We know F is here. We still have all of our rules. And we know we have a floater L. Now, we have two further options here. M can be before F, or M doesn't have to be before F. So let's break this up into two further options where we have M before F, and then we have our G and our K, and we still have our floater L. Or we can have F before M. We have F here, then we have M, and that's going to trigger rule number 3, because when F is before M, then L is going to be before H. So then we have L here. Both L and M are before H, and then H is still before G, and G is still before K. So these are the two options if M is before H and K. Now let's draw out the other option of H and K being before M. So we have F, H, G, and K. We're saying M is going to be after H and K. So that means M has to be here at the end because we have to have K and H before it. And this means that F is before M because F is before G and G is before K, and we know M has to be after K. So F being before M again triggers rule number 3, which means L is before H. So we can place L here. And this is going to be our diagram for if M is after H and K. So what does this tell us? It tells us that the only options that could be first are either L, F, or M. So we can draw that into our diagram. We know that the only options that could be last are M, K, or L. So we can draw that into our diagram. And we know that the only option that can be second to last is going to be either K, G, or L. So we can write that into our diagram. So now we have these two options. Well, technically, we've broken the first option into 2, so that gives us 3 options in total. And we have our rules and our setup and our deductions. So now we're ready to hit the questions.